Hello, CHistrue here. Let's do one more geometry-related video before we move on. So, again, geometry is as much an exercise in logic and philosophical reasoning as it is mathematics. So, geometry is going to be about stating proving our claim. And I'm going to prove a claim that if I have an angle that is formed from a point on the circumference of a circle and two other points in the circumference of a circle, okay, any given angle formed that way, it is going to be, the measure of that angle will be 1/2 the angle formed by taking one of those points and substituting in with the center of the circle. Okay, so I have here angle B, which is formed by, really you can call it angle A, B, D, okay, so it would be this angle formed by points on the circumference of the circle, and that is, the measure of that is 1/2 that angle formed when I substitute this point for this point, the center of the circle, and keep the other 2 points, okay, and that would be angle C. Alright, now, why is that? Let's find out. And this red line here is simply the diameter of the circle, just to make the point that this is the center of the circle. Okay, so prove that measure of angle C is equal to 2 times measure of angle B. Some ground rules, some givens. Okay, first of all, given line segment AC is congruent to line segment CD is congruent to line segment BC. Well, really, that's derived from the property of a circle. So, again, these are radii of the circle. And so they are going to be congruent. Also given is that I have to clarify that when I have my angle A, I kind of flubbed that. Angle A should have been the whole angle, but I just made angle A the outer angle, okay, the part that's in red. Same with angle D, because I forgot that I was going to do a dotted line down there, and I said, oops, but I already did all the colors and all the hard work of constructing this. So this actually should be, this part in the red that says angle A should really be angle BAC, and then that together with angle CAD should be, the whole thing should be angle A, but I didn't do that, so I apologize. So when you read angle A, just read this outer angle BAC, and the same thing with angle D, just read the outer angle there, which would be CDB. So my apologies. I did keep angle C as the whole angle formed from these 2 radii of the circles, and then I also had the presence of mind to keep angle B, this whole angle that is formed by AB and BD. So hope that isn't too much of a problem. Okay. Measure of angle A is equal to measure of angle CBA. So this angle in the red is, its measure is equal to that angle in the red here. And you can derive that based on the fact that the triangle ACB is an isosceles triangle with 2 equal sides. And so the angles opposite, their measures are equal. Okay. The same thing with D and CBD. Okay, these 2 angles in the green, and again, because it's an isosceles triangle, the angles opposite the 2 equal sides are congruent angles. Okay, so angle D is congruent to angle CBD. Okay, and voila. Now I also note that this angle CAD, is congruent to angle CDA by the same method, because this is also an isosceles triangle. So, and then we have the dotted line at the bottom, line segment AD, and that forms yet a second triangle. So we have our big triangle, and then we have our second triangle, and that's going to be important for the next line below. Okay, what on earth am I doing here? Measure of angle A plus measure of angle CAD plus measure of angle CDA plus measure of angle D plus measure of angle CBD plus measure of angle CBA is equal to 180. And that's the property of a triangle. That's supposed to be an E at the end there. Okay, so all I did is I added this angle, this angle, this angle, this angle, this angle, and this angle. In other words, I added all the angles of this big circle up together and got 180. Okay? Now also, and that's of course the property of a triangle, angles of a triangle always add up to 180 degrees in Euclidean space. Okay, now what am I doing here? Measure of angle CAD plus measure of angle CDA plus measure of angle C is equal to 180. That's just adding this angle CAD, the one on the inside, plus this angle CDA, the one on the inside, plus angle C. All of their measures added together getting 180. Because again, this smaller triangle is also a triangle adding up to 180. And then what I do is I take this number sentence and this number sentence, and I subtract the left sides and get the left side of this sentence. And then I subtract the right side, 180 minus 180, and I get 0. So the CAD and the CDAs cancel. Okay, and so what I get is measure of angle A plus measure of angle D plus measure of angle CBD plus measure of angle CBA minus measure of angle C is equal to 0. Now, just doing a little algebra, which is just really adding measure of angle C to both sides, I get measure of angle A plus measure of angle D plus measure of angle CBD plus measure of angle CBA is equal to measure of angle C. Now, what on earth does that mean? Where's measure? Because this is important. This is angle A on the outside, so that measure, again, it should have been BAC, I apologize, but it's measure of angle A on the outside plus measure of angle D on the outside, just the part on the outside, the outer angle, CDB, not the inner part. Don't look at those, just look at the red and the green, okay? Those two angles plus this red and this green here add up to this entire angle C, which if you think about makes sense, okay? Because these angles all added up, well, if you think about it, it makes sense because this plus this plus this plus this equaling angle C, and then if you added these two angles, you would get to C, you'd get 180, but if you added these two angles to this, you'd also get 180. So there's an equivalence there. Remember our equalities here in this line? Measure of angle A is equal to measure of angle CBA, measure of angle D is equal to measure of angle CBD. Also measure of angle CAD is equal to measure of angle ADC. Well, if you substitute in using those, you will get 2 times the measure of angle CBA plus 2 times the measure of angle CBD is equal to the measure of angle C. Okay, that's again because I have angles that are equal. I have, let's see, what do I have here? Even I get confused. All right, measure of angle A is equal to measure of angle CBA. I can just substitute in and measure CBA for A and get 2 times the measure of angle CBA. The same thing for my other equality, and then get this sentence here. But it is also the case that measure of angle B is equal to measure of angle CBA plus measure of angle CBD, as established simply by construction. The entire angle B would be the angle in the red plus the angle in the green. That's all that this is saying. Okay. So, well, again, this number sentence here, 2 measure of angle CBA plus 2 measure of angle CBD, would be twice this number sentence here. Okay, measure of angle CBA plus measure of angle CBD. So again, by substitution, you would get 2 times the measure of angle B is equal to the measure of angle C, and that's what we initially were trying to prove. So we have now proven for all angles, so inscribed, that the angle formed from the center of the circle will be twice the angle formed from the opposite part of the circumference of the circle here. And that includes, by the way, the special case of the right triangle inscribed in the circle, which is what we proved last time, because the diameter of the circle would form a 180-degree angle, and yet from here all the way to here, and yet the point, if I were to form a right triangle with the 2 endpoints of the diameter, that would form 90 degrees. So this would be exactly 1/2. Well, hope you enjoyed the proof. CH is true.